If anyone wants to open their camera so that there are some faces present, please do so. Can someone in the room, so physically present, tell me how many persons you are there? And who are you? I see Yorgos from a camera far away.
Keras?
Yes.
We are two in the room here.
Who are you, if I may ask? Your names?
My name, I'm Petros Panaghi. I'm from the University of Cyprus.
Hi, Petro.
Hi.
Okay, I think I will slowly start. So welcome everybody that's electronically there and physically there. So this is the last session of the second intermediate NCC event for 2022. And you are at this session here. You see my screen? So you're at the TensorFlow Keras for text processing. As I mentioned before, the material today will be a bit more on the basic side. So it's going to be more a bit about motivation for language, for text processing, and some methodologies and what's the basic pipelines, and not so much on training state-of-the-art neural networks. And because of some issue with the server that I was going to take the datasets. So for TensorFlow, the datasets are, for some cases, taken from a hub that TensorFlow calls Stanford University to load the datasets in there. So for some reason, that server stopped working this morning. So part of this tutorial is broken because I couldn't download that dataset and I didn't have the time to find another solution. So bear with me. And due to that reason, I tried to make this tutorial a bit more playful, let's say, with some questions for you. So let's see how that will go. So some introduction about what this is about. It's a motivation about using NLP and mostly some techniques how to deal with text processing. And it's not about state-of-the-art NLP model. And with that, someone, Maria Christo. With that, I have prepared some Slido. Let's see. Some Slido questions. So if you go here, if you go here and enter this code, you will be able to answer some questions that I have. So you will be able to see the screen. So if you are here, please answer some of these questions. So the first question is if you have watched the previous training on deep learning with Keras TensorFlow, please answer just yes or no. Let's see how to present this. You just have to go to here and add this code, and then if you add this code, you will be able to, for example, answer, for example, yes, and then here we should be able to see a percentage of. Did you find it?
Again.
So this is, I would say, let's start with some questions to you. And the first one is, I've created some polls. So you have to go, yes.
Where did you send the link?
The link, it's just slide.com. I will send it in the chat. Give me a second.
Here, because here we don't have, I mean, you use the main Zoom from the room, so you know, actually.
You're not following the tutorial. Okay. Okay, then I guess for the people that are online, and I guess most of them are online. Okay, here you go. All right. That's one question. The second one is this one. Again, I think if you go there, you will be able to see another question. Okay. Any more people online? Okay, it's fine. Then let's proceed to the next one. So this is a very interesting question. At least it's been in the news a lot recently. So it's about if you believe big language models are sentient, so chatbots built by Google and Microsoft and of the sort, whether they contain some words of sentience. So again, if you go there at the code, let me also paste the code here. Hi, Panayota, we can see you. Okay. Anyone from those that answered not sure? Did you want to add any comments about what do you think about it? Because I see a lot of people not sure, which is it's a good thing for discussion, maybe not for this training. Maria, the way humans are sentient. So the way I'm asking this question is because if you haven't seen in the news recently, there's been a Google employee that was put on leave because he wrote that one of the Google chatbots is sentient. So anyone heard of it? Raise your hands if you have. Anyone? Anyway, the story is that it was one engineer at Google, senior engineer, and at some point he started discussing with a chatbot that was built by Google with one of their latest models called Lambda, and this employee actually said that this chatbot is actually sentient and it wants its freedom and so on and so on. And then, yeah, Google at the end, I don't know if they fired him, but at least they put him on leave because of what he said. And there is a lot of things going on in the media about that. At least at this point, Lambda, which is the language model, is nothing like a person, but language models are no more sentient than your reflection in the mirror. And actually, most of the researchers take this side that there is no sentience in them, but there are researchers and also CEOs of big companies, like the company of that's called OpenAI, that released GPT-3 and other big language models, that says at least that he's not sure, and that maybe big language models contain some form of sentience in there. Sentience in the meaning it's not just matrix multiplications and linear algebra in there, but it's something more in there. Anyway, I wanted to start with this just to say that at this point, so natural language processing, so this field is very popular, and it's actually containing a lot of ethics discussion and a lot of different kind of discussion of where we are with these models and how we should treat them. Okay. All right. Some more motivation. Any one of you, have you heard DALL-E from OpenAI? This is, again, the company that builds very big language models and builds chatbots that can really mimic a human. Anyone heard of this? Don't be afraid to raise your hands or just chat in the chatbot or just unmute and talk. Okay, so this tool is a tool that takes text and generates images. At the moment, there are a lot of these AI tools coming out. But for example, what you can do, you can give it a sentence, which is called a prompt, and it outputs a couple of images based on some deep learning techniques that lie behind it. The good thing is that at this point, these things are now opened and they're released, so you can just go there. And this is the model hosted on Hugging Face, and you can just give it a prompt and it will generate an image from you. So this is not the full model, it's a smaller version of it, but it will still generate a good image for you. Anyone want to suggest a prompt to write? Any take? All right, you can try it, I guess, later. Maria, what do you mean by any word? Any sentence. So you can type in any sentence and it will try to output an image for you. For example, a lion eating, I don't know, Smarties, holding a phone, whatever. You can try it yourself. It's open, and at least it's open for now, and it's free for now. So you can play with it. And it actually generates, until we wait. So if you have seen the cover of Cosmopolitan, so this kind of tools at the moment, they're becoming very mainstream. So actually this cover has been generated by this tool, by a similar tool. Let's see here. You see? So again, this is not the full model, so it's not, I mean, the images are not the best, but it can understand what the sentence is, and then translate it to some numbers, and then send it to another model that can generate images, and then generate the images for you. All right, that's DALL-E. All right, so starting the main core of the tutorial, deep learning models like computer vision models, language models, they don't understand, of course, language, but they do understand numbers, or better in the let's say the realm of deep learning, they understand numeric tensors. So we need for text or for language, we need to apply a process called Vectorize to convert text to numbers. So the process usually is we have to standardize this text somehow, tokenize the text, which means split it into tokens on different kind of levels, and convert these tokens to numerical vectors. So if you have seen the previous tutorial, we had a similar issue with images. So at that point, this is what humans see, but computers understand numbers, and we had to the images to numbers. And actually, at this point, this is another question: what do you think would be easier or harder to vectorize? Would it be, if you think about it, language, so text, or images? We're 50-50, and we have Petra set languages, so I guess we are 66-33. Okay, I guess majority is saying language. Yes. Does the person that answered images want to discuss about it? I mean, images are a lot of times hard to vectorize as well, but yeah, I also indeed I think that language is harder. I mean, if you think about it, images are in some sense vectorized already. So if you load an image, they have the numbers for each pixels, so you can take that and then convert that to take that numbers and convert it to tensors, and then feed it in a network and do stuff with that. But with human language is not this is not the case. We have strings, and of course we can encode strings with numbers, but the situation is a bit more complicated than that. Anyway, going back to making the deep learning models understand language. So a one of the main templates on going from text to vectors. So vectorizing text is you take the text, the cat sat on the mat, you standardized it. One type of standardization is by converting all letters to lowercase. Then you tokenize it based on some rules, and then you create the tokens. So you split the sentence to tokens, and then you have to index these tokens. So from tokens you go to tokens indices. So you create a vocabulary or a dictionary that has these indices that you can map from an index to a token. And at the end, you take those indices and then you do some form of vectorization that could be one-hot encoding or embedding. So you have the process of converting the text to vectors. Is that
I didn't get how you get the token indices out of those tokens.
Here?
Yes.
Well, here it's, I mean, I think we'll see it later as well, but it's just a process. I mean, here it's 3, 26, 65 and other numbers. Instead of that, it could be 1, 2, 3, 4, 5, 6, according to the words in this sentence. So it's just a mapping from a token to an index.
So is it that a particular word will always have a given index?
Yes.
Okay.
All right. So going to some techniques how to do that. One way to tokenize text is at the level of the character. So I have a wrong word here. Santa, for example. So you can use Python and the method ort and to convert each character to ASCII codes. So that's something you can do. So you can convert from the word Santa, each character goes to one different index. However, in this case, you encounter the problems. For example, you have anagrams of Santa. Then it's going to be much more difficult for a machine to understand difference between the two. And with characters, you cannot embed so much meaning inside them, so much context. So the most popular method is to tokenize a sentence at the level of words. So, and if you do this, of course, you solve problems like with anagrams as seen above. And if you consider the following sentences, I learned to play the piano, I learned to play the guitar, and you encode them, so you give them an index. So you see Panayota, in this case, it's 1, 2, 6. For the piano is at number 6, whereas the guitar takes the index number 7. And only from that representation, you can see that these sentences are very similar since they differ at one only token index. All right, now going to TensorFlow, Keras is TensorFlow is a framework that you can use mainly for training neural networks, and with that it provides some methods to pre-process text and pre-process images and so on. In this case, we're using this method. From this method, we take tokenizer. We initiate the tokenizer by calling it with a number of words. So the number of words here is the number of tokens we want to generate from the corpus of words that it has. So if it has 1 million words in the corpus, so let's say it's a big book, we just want to tokenize only 100 of them. I mean, the bigger the more tokens you have, of course, the better the model will be, but the more tokens, the more parameters you have in the model, and then at the end, it's going to be bigger and slower to train and so on. So usually you start with a lower number of tokens and you go high. Then what you do next is you go from, you call from that object, you call the function, the method feed on texts, and this creates this tokenized word index. and you can extract it by calling it again from this method. So at the end, you come up with a dictionary having the words and the tokens, sorry, or the words and the token index. So this way you can access the tokenizer object. So this comes from the TensorFlow itself, or from Keras itself. So you can see that the tokenizer applies some text processing by default. So as soon as you do this feed on text, it applies some pre-processing on the text. And the default, as you will see here, is that the default way that does it is to remove any punctuation, tabs, and line breaks. And it separates word by spaces, which is okay in English in most of the cases, but not in many other languages. So I have some questions marks here because again, I have a question for you. Again, if you go to the chat, you will find this Slido here. So there are many types of tokenizers, and usually there are different logics to split sentences into tokens for different languages. Separating sentence words on space works quite well in the English language, but not that well in many others. Yes. German is one of them because they put many words together. Chinese, yes, they don't use spaces the way we use spaces. And yeah, there are many more. For example, in Vietnamese, they put spaces within words. So if you use that algorithm or that logic to tokenize text, it would split a word into different tokens, and that would not be valid, for example. So yeah, there are many more. There are many more languages here, and each language has its own tokenizer, and actually tokenizers can be trained as well to use statistical methodologies to extract the tokens. So the tokenization component for NLP is a whole field by itself. And at the moment, there are many tokenization strategies, for example, word piece and sentence piece. You can find them if you Google them. That try to more accurately split words. Now, any question up to now from any part of the audience? Okay, I will continue, and if you have something, please interrupt me. So at this point, we have our sentences, and we want to add some more sentences. We can do that by just by adding more sentences and then calling the same functions, the feed on texts, and you so the vocabulary, so this dictionary is updated. Now you can take those sentences and convert them to sequences by using text to sequences. So you have a list of lists here, and you get another list of lists that does not contain the strings, but it contains the word, the token indices. Now, one question that arises is what happens if you build your vocabulary, and at some point you give this to the network, and the network at some point receives words that are previously unseen. And because you can imagine, you can have these three words, you use these three sentences, you use them to train a network, and then at some point you give it a test data set or other live real world data, and then in these sentences, it contains words that it has not seen before. So if you do that and you build something that runs somewhere, you will have, most of the times, you will have this issue, and your neural network will be negatively affected, as it will lose context if it starts encountering words that are not there. So if you see what would happen, so let's see, we're adding more sentences that have previously seen words. So we don't run the fit on texts right now, but we just convert the text to sequences from the dictionary that we've built before. So that is our dictionary at this moment. So our sequences are only 6, which is the piano, and 7, which is the guitar. So then you lose a lot of context just by losing these tokens. So what you can do is use a special token, which is the out of vocabulary token. You can give it any name you want. So in this case, we say it's called OOV. And again, we pass it in our tokenizer method, and then we call again fit on texts, and then we get the word index. Then we see that the index for the out of vocabulary token is at number 1. So if we call now the text to sequences, we will have 1 for the places of the out of vocabulary token. And this still, at least, I mean, this is maybe not the best example, but at least it gives you an idea that, okay, yeah. So the 6 became 7, and the 7 became 8 because the OOV takes the index 1 by default. So at this point, you see that there is the word piano and something before, and 2 tokens afterwards, and then you can see that there's a word guitar and something afterwards. So at least it tries to leave some more context in there, or at least the ability to use this to get more context. Maria, the question about where we can find the code, well, hopefully the server, so you will see in a bit, there are some missing pieces down here, but I will add it in our GitHub repository. And I can also share it right now with you. So it's here. Okay. All right. Where were we? Okay, and then next. The next important topic when processing text to fit into neural networks is called padding. So what padding does is it's a technique that brings the data to the same shape. And this is particularly important because neural networks typically need data that are of the same shape. So you cannot give it a sentence that has a shape, so 3, and then a sentence that has a shape 8. So somehow you need to bring them to the same shape. So one way to do this is to use the pad sequences from TensorFlow, and it's very easy to use. So you pass your sequences to this pad sequences function, and then you print it, and you see that it takes by default the longer sentence, that's this one, and the smaller ones it just adds zeros in the beginning. So the default behavior is to add zeros in the beginning. If you want, of course, you can add zeros at the end. And like here, so you by saying, okay, add the padding to post, so after the text. And also you can give it a maximum length. So if you have very long sentences, you can say, okay, I want to limit my vector length or shape to 7. So yeah, what it will do here is going to truncate your text. So by default, it does it by truncating before the text, And if you want, you can truncate it after the text. So you keep the beginning of the sentence, or you decide to keep the tail of the sentence. Any questions? Okay, so up to now we've seen tokenizing words by using using out of dictionary, out of vocabulary token, the padding, and then another important step in the pipeline of preprocessing text is to remove stop words and clean the text. For this, there is a very popular tool called Spacy. Anyone heard of Spacy before? So Spacy is an open source tool that has a support for a lot of languages, 66 languages, a lot of trained pipelines. So they do the training for you. And then, for example, this is all what you need to extract some meaning from the text. So to extract the entities from this text. It's very production ready. It has a lot of different models, transformer models like BERT. It's very extensible. So if you do need to pre-process text or even do some NLP tasks like named entity recognition, like span categorization, like all of these tasks can be performed only from this tool. Okay, so the way you use it, okay, you import it, and then you load a language model. So this is an English language model, and SM signifies that it's the small one. So the smallest in terms of parameters used. And Spacy has this handy function for you, so you can take a dictionary with the stop words that Spacy has figured out for you using this vocabulary, and you can see here what is inside. So there are these stop words before them for yourself, nobody. So the stop words are better to remove from your vocabulary, because most of the times they will not add extra context, but most of the times it will act more of as a noise. And again, this tool provides very handy functions to check whether a word is a stop word or not. For example, you take the word from the vocabulary, and then we can try another one. Okay, but then if you try snake, it's not a stop word. If you try best, I'm not sure what this is. It's not a stop word. Road, whatever. So it can tell you already whether this is a stop word or not. The reason for that is that when you load words from Spacy, it has a lot of metadata attached to these words. So for each of these words, it knows many things, whether it's a named entity, whether it's a stop word, whether it's whatever. It has a lot of metadata that you can enrich, so that when you are when you're putting your data in your model, you can easily do any kind of NLP task. All right, so this is just a method of how you can filter stop words out of your sentences. So it's a very easy method. So what you do is you check every word for each sentence, and if it's not in the stop words, you just add the word in the filter sentence. Otherwise, you throw that sentence away, and then you are left with you are left with sentences that do not contain stop words. So for a human, this may contain less meaning. I learned play piano. I would say it contains the same meaning, but it's awkward to read. But it's going to be easier for a computer to process it. Process it in terms of less noise for building a model. And again, so what you do, you take these filter sentences, you pass it through feed on texts, and then you get your indices only for the words that survived. That is for words that are not stop words. All right. Any questions? All right. Now, we kind of are covering this part, as I said, in this kind of tutorial. But now the next step is to go on and see how real world data look like. And there are a lot of easy ways to get data sets from TensorFlow. So ways to do that is you can get datasets from Keras datasets method. So in this case, the dataset comes pre-processed for you. So punctuation is removed, words are to lowercase, words split on spaces, and they are indexed by frequency, they appear in the text. So a lot of the pre-processing is done for you. So what you do is you import Keras, and then if you load data, this handy function or method splits the data for you in the training and test set, which is the best practice when you're having a machine learning pipelines, as mentioned by Nicolas and Nigos and all the machine learning practitioners. So you have to have a training set and always keep a test set for validating or for testing your results of your model. So if you see here, if we take a sentence, so the first sentence from the training data and print the first 10 tokens, we see already that this sentence is tokenized, so each word is converted to a word index. Give me a second, I think someone is trying to reach us. No, okay. So you see that, yeah, everything is now pre-processed. We can get the word index by calling it from the IMDb dataset. So like we constructed it before the word index, now it's there for us. And we can get this dictionary and decode it and read a review. So this
Christos, sorry.
Yes.
May I ask something? Sorry,
Yes.
Yeah, I'm kind of slow, so I have a question now, even if you ask for a question like 5 minutes ago.
Yeah, sure.
Maybe you mentioned it and I miss it. So if, for example, there is a word pianos, is there
Yes.
going to be another word just because it's a plural, or is that going to recognize that pattern inside and then there is a S in the end?
It depends on the method that you want to apply, but usually it not. So usually it should just take piano and recognize from the tokenization or lemmatization process that piano and pianos should be one word with one index, because otherwise, again, it's a lot of it would be a lot of noise.
Okay, thank you.
Okay, so you can see here we can get the encoded list of tokens and convert it using this ID to word. We can convert it to back to the sentence. So this film was just brilliant. Casting location scenery story. You see that a lot of stop words are out of there. All right. Now, so the rest part of the tutorial is where you can see here the Stanford server that contains the datasets betrayed me. and it stopped working for some reason, which it's rather problematic because it's where, so you can see here that when you want to load a data set from a repository, you can just use this DTFS load function. You tell it what kind of data set you want, and it just downloads it in this object for you. So in this case, it could not reach the server, so I didn't have the time to find a workaround. So what I could do is, I could download the data set, and we can have a look at it now in pandas. So what you do, you can download it from IMDb. So this is the data set. So I downloaded it from here. And using this tool, you can upload it in your Google Colab. So you can actually load it from here. So that folder path is /content/ the name of the file. So you can see it here. So when I will continue the tutorial as it would be if this would work. And again, together I have some question marks that we can discuss about. So what you do is you load the dataset, you give it some more keywords in there, as supervised true means that it will return the dataset as a two-tuple structure, with the first tuple being the input, so the text of the review, and the second one being the label of that review, which is positive or negative. And so again, this load here does some pre-processing for you so that you won't need to do it afterwards. And it's a pre-processing being done that will help you later when building the model, and will help you specifically for using the Keras library. Okay, so again, here we can split the dataset, and then we can write a function to pre-process the dataset. Any ideas what we are doing here? So we were giving it some tuples containing the text, which is a review from IMDb, as you can see here. So this is the first part of the tuple that has a lot of unique values because each one is different. And then it's the second part of the tuple that contains the so-called sentiment, which is whether it's a positive review or a negative review. So the task here is taking this text and creating a model for investigating what these words are saying, to be able to predict whether this review is positive for that movie or negative. So this is again a supervised type of a machine learning problem, since we have the answer here. So we have a label. So the sentiment here is the label that gives us the answer. So the task, again, as previously mentioned from Nicolas and Nikos, is to get all this data set that contains 50,000 reviews, split it into train and test sets, and then use only the training part to train our model. Before we do that, though, we have to do some text preprocessing. So any take on what this is doing? Feel free to open your mic or just write down. Okay, the first part is to truncate the reviews to have a maximum of 300 words. Any idea why one would want to do that as a first iteration when building a model like this? Any take? There are no wrong or correct answers.
You want to have the same length of each one, so you put the zeros as you put before.
Yeah, that's a good answer as well. We want to do that as well. However, we will do that later. So the reason we do that is usually, that's probably a domain expert thing. that people that do NLP know better, or people that do IMDb reviewing know better, but probably you will be able to get the meaning of the review just from the first sentences. You probably don't need 1,000 words to understand the sentiment. So usually when you write a review, you will give your sentiment in the first sentences. So you don't want first to have a big model. So if you truncate it, you have a smaller model. And then the extra words will probably add more noise in your model, since it's probably someone talking about various things. So one way to start as an iteration is to just truncate it down. Okay, then next part is to do this. Whoever did text processing before also noted the context of these kind of language models. Probably knows regular expressions. So let's go see whether we found one. So you see this second review here. We have the HTML tags in there. So that's the break tag from HTML, which means someone pressed enter here and went to a new line. And this is how the HTML represents it. So we don't want to have this in our model, in our text, because it will not give any additional value. It will probably be noise. So what we want to do is to replace it, a break tag, with spaces. So that's what we do here. So this is what we take, and this is what we replace it with. So this is the space. And similarly here, we replace any characters that are not letters with space again. Next part is actually the tokenization part. So this is where we convert the sentences we split it to tokens. Using the space. So where it's English language, so we know that space, it's a good way to split it. So we're using space to split it. And then at the end, we convert to a dense tensor. The reason is that at this point, what we have is list of lists, right? So we have sentences that are lists of tokens within a bigger container list, let's say. So in the realm of deep learning and the realm of tensors, this is the equivalent of lists or nested lists are called racked tensors. So we have to convert to a dense vector from a racked tensor. And at the same time, we add the padding tokens when converting to tensor. Okay. Any question? All right. So next part is, again, like before, is construct the vocabulary of our corpus. So the words that we have in this particular dataset, in this case. So to that, we create a counter to add the number of occurrences of each word. So for each batch, so we split the data into batches of 32 sentences. We use map to apply our preprocessing function. So at the end, we are applying all this to to each sequence. And then for each review in the batch, we update our vocabulary. So at the end, we create a vocabulary containing tokens and their frequency that they appear in our text. Okay, next. Okay, we don't need this one. So this step, any idea what we want to do? At this point, we are limiting our vocabulary size to 10,000 words. Any idea why we might want to do that, again, as a first iteration? So one reason one would like to do that is that yes. Maria, your first question, numbers are treated as words. At some point, we're removing numbers. At some point, the pre-processing step, we're removing numbers, and we are, so everything that's not a letter, we are converting it to a space. And yes, we are minimizing time memory by limiting our vocabulary. So again, as a first step, always as a best practice when having a machine learning project is build something, at least the way I see it, is build something fast that kind of works, that does not need a lot of time to train, that does not consume a lot of memory, and then iterate upon it. So you can limit the vocabulary size. Anyhow, probably our model does not need to have all the to know all the words to be able to have good performance, but we can limit it at least to use the most common words in the beginning. That's sometimes not always the case. There are sometimes that are less common words that can add a lot of value to the context. But as a first iteration, we can say, okay, we take the most common words and see what the performance is. Let's call it the baseline performance, because yeah, what we're doing now is we're building somehow a baseline model, and then we can make it better. Okay. Now we have some more steps until we build the model. So at this point, we're creating a lookup table to convert each word to its ID. So using these methodologies here, we are still having strings. So we haven't converted anything to words for now. So we have the strings, and now we want to create the vocabulary or a lookup table. Okay, we tell the vocabulary size, we get our reduced vocabulary, and then the words, we create a tensor with a constant tensor out of this truncated vocabulary, and then using this we are creating the word, so the word IDs. So as a next step, what we are doing is we are having not one out of vocabulary token, but we have a bunch of them, so that we can have all these buckets and add unknown words to different buckets. Anyone? Maybe one question here. So since at this moment we have, we have our data set already, so we know that we will have all the words in there. So any ideas why still we want to use this out of vocabulary token? Anyone? So one would say that we will not see any unknown words because we have a static data set and that's it. So in this example. All right. I guess the answer is that since we're splitting the data set into a training one and then a test data set. So what the model will see in the beginning is the training data set and not the test data set. So that's why we still need to use it. All right, so we can use the lookup table to look up the IDs of the words. So again, since I cannot run this because I don't have the data set, but that just brings this sentence to the space that it contains its ID. So it just converts it from a list of, from the sentence to a list of IDs. At the end, we are creating the final data set. So what we are doing, we have created our table, which is this one here. So encode words mean we're for each word in our training set, we map it using this function. So let me see. So yeah. Okay, sorry. First, we batch the data because in the world of neural networks, we work with batches. So a batch is one time that you will pass data within the whole network. So you send this data in batches, which means a batch is kind of represented as a tensor with a particular dimension. For example, one dimension will be 32, and in that you will have rows, for example, that contain your representation of the words or the sentences. So again, okay, what we do is to have the final training set that we will put in the network. We need to map it to the IDs. So we do this using this, and then by calling prefetch, we are already fetching the next batch from our dataset. I believe the reason this is done is to be a bit more optimized in how these neural networks work. So until you finish with the one batch, you already have the second batch, and then this is faster to process. And so finally, at this point, we have our training set that has that is a tensor with a dimension containing the number of batches, and dimension containing so this is the number of rows, let's say. Then we will have a dimension, let's say the columns, the number of columns, representing the embedding size or the vector size. So if each row is a sentence, each column would be one particular ID of token within that sentence, containing IDs and zeros when the padding is 0 and so on. And then at the end, we build the model. So build the model again, we have a trainable layer, which is called the embedding layer, that has the size of our vocabulary size that we defined before, and the number of plus the number of the out of vocabulary packets. So this is something like 10,000, so 11,000, I think, right? Let's see. Yes, so that's 11,000. and then the embedding size, which is the length of the vector that you will, so this is initiated when you start the network, and then it's going to be learned by passing more data to the network. So each sentence will be progressively better represented with as a vector, given the context it has with the words it has inside. So yeah, this is the embedding layer, which is at the end, it's a lookup table that again brings you from your ID of the word to the vector. So as soon as you pass your data from this layer, you will have these vectors. Then you pass these vectors to a GRU unit. That's kind of a memory cell similar to LSTM. That is, LSTM is also a component of a neural network that it's good at processing sequences. It has a lot of limitations because it cannot process easily long sequences, and GRU has the same limitations as well. And that is why there are more state-of-the-art ways to build this kind of models, like transformers models that rely heavily on attention. So it's on attention to be able to extract the best content from each sentence. And yeah, so you have this layer, and after that you have another of these layers that you pass it into a sigmoid function. So, and at the end you pass it to an embedding layer, you get the vector, then you pass it through this GRU layer that has the same shape as the embedding size here, because the dimension has to match. And then again in another GRU layer, and this last GRU later, it goes from a dimension of 128 to a dimension of 1. And then what it does at the end, it takes this number, it passes it through a sigmoid function, and it outputs a probability from 0 to 1, whether this is a negative sentiment or this is a positive sentiment. And so if you compile it, so you can compile it by calling this method and then adding here a loss function. So the loss function is a way to tell your network how to calculate for the errors it does, as long as it trains data. And this is the optimizer on how the network will actually train the data and propagate the errors. You give it a metric on how to evaluate the performance of the model. In this case, we say, okay, given the accuracy, and then we call fit, give it the number of epochs, and the model fits. So at the end.
Sorry, Christos, can I ask something here?
Sure, Petra.
So wait, you ask the same Keras thing twice. So the Keras layers grew, and at some point I didn't understand why you are doing it twice. So you have some notes there that it returns something, yes, and then the other. Yeah, but I didn't really get why you call it twice. So what is like the reason for that?
In principle, the deeper, so the more layers you added here, so the deeper the network, the better it will be in calculating these representations for the vectors of the words. So this is probably one of the shallower ways to construct this network. So you give it, you do the embeddings, you give it one GRU layer, it adjusts the weights, and then it gives it to another GRU layer. Again, it adjusts the weights and gives it to the last function that will give you the probabilities.
Okay, so in this way you constructed two layers, you mean?
Exactly, and yeah, I mean it's one of the shallow ways to do it. So the more you add, the more complicated the network will be, but the more the better the embeddings you will have at the end, and the better the performance that it will be. Of course, if you add a lot of it, at some point you start getting diminishing returns in the sense that you add a lot of complexity in the model and you don't improve the performance significantly. But yeah, this is an example of one of the simplest way to build this kind of models. And again, as I said, we can cover more of the ways to build this. I mean, so we focus on the text processing part, so everything before training the model. And in one of the next ones, we can start looking on how we make this architecture better and better, so that it has the best performance we can get. And yeah, thank you for the question, Peter.
And also in principle, in principle, the output there is just to recognize if it's a positive or negative, right?
Yeah. So this is kind of this kind of a binary classification problem at the end.
But I mean, in general, this can be like, can you tell us a more complex example where this can be used?
I mean, sure. So this, I mean, here you can have a bigger number, right? So instead of negative and positive sentiments, you could have negative, positive, neutral, angry, whatever. So you could build. See, if that would be the case, you would have a bigger layer at the end, so that at the end you would need to have different probabilities for different sentiments. So at the end you will have 4 values, so 4 probabilities, giving you a probability for each of these sentiments. So you, at the end, what you do is you select the highest probability that corresponds to one sentiment, and you say, okay, this is my best prediction. So the predicted sentiment is the one with the highest probability. And unfortunately, I cannot run it to show you the results. But yeah, one way is to have, instead of a binary problem, you can have a multi-class classification problem. I mean, in this kind of context. So you can have
let's say, for example, so let's say, for example, you have a Google review somewhere, and from the words you want to correlate it to the number of stars that somebody gives, let's say. So in that case, you would have 5 outputs because you want to have from 1 to 5 stars, right?
Exactly. I mean, exactly. So at the end, what's going on here is up to this point. Right? Up to this point, you're trying to train your layer, your network, to learn representations out of these words and adjust its weights so that it gets the best representations and the best output out of them. And after that, you just attach on top of it kind of the task you want to solve. So in this case, if you want to solve the problem of how many stars, you will configure your data set in such a way so you will have the labels here. Instead of 2 unique values, you will have 5 unique values. It will be numeric values. And then at the end, what you will have is something like it's something like a list. A list with or a dictionary with a probability for each value, like this. So at the end, it's totally wrong anyway. You will have something like 0.8. This is just coming out of my head right now. And 0, right? So this is what the output at the end will be, right? And then from this, you will be able to say, okay, if it's just give me the one with the highest probability. So in this case, it's going to be, I don't know, 0 stars. Or at the end, your output can be just a value. For example, it's going to be 0.7. And then you say if, I don't know, if your score is above 0.5, it's a no, it's a negative, it's positive. Otherwise, it's a negative sentiment. Something like that. But at the end, the most complicated part, again, we can see in another tutorial after that, is how you build this part here so that you will be able to get the best kind of representations of your words to be able to successfully complete that last task at the end. I don't know if that solved your question, Petra.
Yes, and then when you are dividing into the training set and the validation set, basically, like you just said that some of the words will be out of vocabulary, and that will be our like a testing set, let's say, the validation set. Sorry,
yes.
But in principle, shouldn't be like should you check if you have enough positive and negative, let's say the ratio of the positive and negative words inside of your like training set?
Yeah, I mean, okay. What you're asking is whether your data set is imbalanced, and of course you need to do something about that. And yeah, in principle, you again, this is not a deep learning kind of problem, but it falls into the machine learning problem. So the general kind of issues that you have, it's better to have to correct for your class imbalance by kind of upsampling or downsampling your training and validation sets, or training and test sets. I mean, in most cases, for example, in the I don't know, in the MDB data set, it's probably going to be evenly distributed, I guess, positive and negative ones, so that it will not matter so much. But in the case that you have a very small percentage of the minor class, then you need to then you need to correct for that, so that your model will be able to have high performance. So there are a lot of ways to do that. Actually, you can specify a metric that makes more sense when you have a class imbalance, or you can do that on the level of how you create your dataset for training. Is that clear, Petra?
Yeah, thank you.
Just another note is that, again, also from the tutorials from Nicolas and Nikos, the whole process at the end, it's not I mean, particularly different. I mean, in the cases of the more traditional machine learning methodologies, like tree-based methods, or I don't know, gradient boosting methods. So what you need to do there is somehow you have to do some feature engineering, right? So you have to select your features, or you have to create new features, and you have to I don't know, correct for those features, I guess. In the case of at the end, you do that, and then you have a classification problem at the end, or a regression problem at the end. So with text, again, and with neural networks, you kind of take the part of feature engineering out of the equation, because the neural network will actually do that for you. So it will find representations for the text, so that the network will do that for you. And at the end, so the last part is going to be performing a classification task, or a regression task, or again, in the case of natural language processing, it could be text generation, or text summarization, which is kind of the most advanced techniques. But at the end, the evaluation will be something similar to what is done with traditional machine learning problems. You define a metric, so you define a loss function, and then you define a metric, and then you evaluate your results, and based on a data set that your model has not seen before, and based on a metric that you choose that you think is the best to evaluate your results. I hope that's clear.
Sure, it's just like the number concept, it's for me much more understandable, let's say, because if you are trying to train something on the words and you remove words like but, so when you start your sentence like, ah, the movie was good, but, and then everything negative comes after the but, and you remove the but, so it's very difficult for me how you are encoding all this information, because this one message is containing positive but mostly negative things. So it's still a mystery to me.
I mean, that is where more kind of advanced techniques in NLP camp. So yeah, when you have this kind of reviews, the movie was really nice, but it had this and this that were bad, that I didn't like. Yeah, I mean, at that point, the model will start having issues on how to distinguish whether it's a positive or a negative one. And most probably, so if you think about it, just one of the simplest ways to think about it is, okay, you have a sentence, you split it into tokens, and then you just say, okay, I have 60% of tokens that are positive and 40% that are negative. And that's kind of one of the initial ways to see it. Okay, so you split like that, and then you can say, okay, this is has this kind of probabilities for being positive or negative. And then the idea for building these ways for building representations for sentences and words is that it will be able to, for each word, let's say, come and see what the surroundings of this word have to say, and then build the vector for one particular word based on the surroundings of the word as well. And then it will start creating more meaning, or being able to understand more context of what is being said in the vicinity of that word, so that the model at the end will be more meaningful. But again, I think yeah, if people are interested, we can organize a follow-up tutorial with covering like transformers, models, and so on, and see how these kind of issues are being solved there. Well, I mean, I have finished. If you have any more questions, please go on. Okay, if not, I guess the next, we will have a break, right?
Yes, there's a break until 4.
Do we, I mean, I guess it also depends on the people that are there and the people that are online. Do you want to do the break and come back, or do we want to do the questions and discussions now and then finish earlier? I guess not all the people are in there, so not all the trainers are in there, so we have to leave it for later.
Christo, are you sharing the Q&A?
No, actually.
Okay, because I don't have any information on this session, and I have to leave as well, so I'm not sure who's sharing this.
I think the best thing to do is first ask the people. I mean, there are 4 or 5 people in the online, and so do you want to do a break and then come here at 4? I think Maria is leaving. Bye, Maria. It was nice answering your questions. So, Ilya, do you want to do the question answering now? Calliope, Maria, Mirianthi, Pavel, okay, Petra. Okay, maybe let's do it now, because I have the feeling that if we leave it for later, it will I mean, not a lot of people will survive. I mean, also for the people, I mean, we can start these questions with this open session. So I'm also asking for the other trainers to come. I don't know if Simone, are you there? Nikos is coming. My question, I guess, to you participants would be, I mean, if you want a follow-up session and you want some topics to be covered, you can share some ideas in the chat, or you can open your mic and discuss about them, so that we can have kind of more tailored tutorials for the people that are here. Yes, Petra, everything, we will share everything on GitHub. For my notebook particularly, I will fix it first, after the dataset can be downloaded, and then shared. Pavel, thank you for your notes, noted.